Now, I'm sure syllogisms is something that many students find painful, uh, but I think it's upon uh, understanding and also memorizing a bit of part, and then particularly connecting it with respect to the exams. Certain different kind of exams will ask different questions based on syllogisms. In certain questions, if you memorize certain stuff, definitely it will be helpful enough or quick enough to gain quick answers. There are certain part that only if you understand will definitely help you and reach the accurate answers. Otherwise, even if you do attempt the questions in exam, it's going to be a bit of dilemma that whether these questions are correct or not. So I will advise that you understand as well as memorize certain parts. I will emphasize on what are the important parts of this theory session that you need to memorize, the parts that you need to. And while practicing, I believe if you try to connect them, use your intelligence to find out whether certain things that we can memorize and quickly gain the answers, and certain things if we are doubtful or unsure about the options, you can quickly go and check back and understand them. So that's the caveat that I wish to share. This class is going to deal with four aspects. Number one, getting to know certain important terms and terminologies that help you understand the syllogistic quantities, qualities, the immediate, mediate conclusion, the definite, and the probable kind of conclusions and the nature of the conclusions. Certain major four statements, that is the A, E, I, O type, which will be definitely covered, and what are the immediate conclusions that must be made. Logical possibilities is my way of solving these questions are. There are numerous methods of solving syllogistic questions, but I will try to stick to a foolproof kind of a method which we'll discuss today. And then in this sheet also, in this video recording also, towards the last, I will be solving a couple of questions so that you gain the perspectives, you watch this video again and understand and memorize the theoretical aspects of it, and then that will really help you ace the other sessions, other questions that I'm going to record in the next video. So without much ado, let's get started with the first thing. What is syllogism all about? In deductive reasoning, basically syllogistic arguments are what are called as categorical arguments. They are in terms of understanding one category of term associated with another category. For example, in this case, I've said all men are mortal, and then Socrates is a man, therefore Socrates is mortal. So these are what are called as the syllogistic arguments. In exams, you'll be given a set of statements which are premises. Then from the premises, you will derive something that's propositions, which will be the conclusions. And in exams, you have to find out whether the given conclusions are valid or invalid. So in today's class, we will try to define how do we validate and invalidate the conclusions that are given to us based on the premises that our questions are going to ask. However, I know this might be very easy and it might be very understandable to understand that, okay, if all men are mortal and Socrates is a man, then definitely Socrates is mortal. In your exams, this is what is called as a sound argument, because it applies correctly to our reality that we live in, and therefore becomes a very easier scale to answer these questions. However, to make it more challenging, the examiner are going to make them unsound. For example, they might give you a question like all cats are dogs, and then says Socrates is a cat, therefore Socrates is a dog. Now, the idea is that you need to understand that it has got nothing to do with reality. You do not have to find out the validity and invalidity in terms of life or their soundness or whether they make sense or not. However, you have to just understand that whether they logically make sense or not, given if the premises are true. So if the statements are believed to be true, can we logically conclude the conclusion that is written? That is our basic point of understanding that we learned in today's class. So we have to define what I call as logical validity of the statement. Now, having said that, let's understand what are the important terms that are in syllogistic arguments very, very important for our understanding or help us understanding the topic in details. The few terms, the first very important term is about understanding the quantity. Now, in syllogisms, there are two kind of quantities, universal and particular. The idea of syllogism I'm later going to deal with is helping you understand via set theory. So let me quickly refer to a universal basically refers to a whole set, while a particular refers to a partial set. And that is what we are going to understand by the quantities that they give. For example, how do we going to understand that this is a universal set or a particular set? It's very simple. If you see any of these quantities in your variable or before any variable, this is representative of a whole set. For example, if you understand here and say, okay, all men are mortal or all cats are dogs, I understand that, okay, this set is talking about a whole set and therefore is a universal. While if you see any quantities like some, few, many, most, at least, certain percentage, certain fraction, etc., then you're going to quickly understand that, okay, this is representative of a partial set. So we are going to quickly practically solve this. Let's say if I just write Socrates is a man, then what is the quantity of Socrates? I'm sure that in reality, if you look at Socrates is a one particular person, but as a set, Socrates is a complete set. So I'm going to take that, okay, Socrates completely is a cat. That is what this variable, that is what this statement claims, and therefore as a set, I'm going to consider Socrates completely to be a cat. And that is what we are here looking for, that even if something is not written as a null set, it's also taken as a full set. So let's clear the mud and say that, okay, in order to quickly grab this and understand, I say by whenever you will refer to a partial set, you will always use these terms, like at least few people are this, at least X is this, or some of them are this. Otherwise, for whatever set, you will be always denoting a whole set. So let's do certain practical applications of it. For example, if I say all dogs are mammals, now all is therefore a representative of a quantity. Okay, and then dogs and mammals are definitely the terms of the variables as I call them, and then R is representative of the quality, but we're going to quickly shortly understand what is quality. But for example, upon certain claims like some dogs are not frogs. Now, if I ask you what is the quantity of this statement, it's definitely a particular. Why? Because you have mentioned some. You talk about a partial set and not a whole set. Therefore, this is a particular set. Also a negative, but just wait for it. Shortly, we're going to understand the negative. However, if I'm going to write each boy in the class is absent, it's definitely a representative of a whole set. Now, let's move to quality. So I hope that is understandable, that universals and the particular, I can use these annotations to make you understand that U represents a universal set and P represents a particular set. A point of important reference is these are not the logical, these are not the mathematical or the uh, grammar quantities. These are about the singulars and the plurals. I mean, these are the logical quantities which will be representative by a whole set and a partial set. So just keep that in mind, and I think you'll be done. Quality with respect to it is also with the two type. We have a positive and we have a negative. Now, again, as a set, what does positive mean? A affirmative set means that the set is included. So it talks about an included set, while a negative talks about an excluded set. Okay, so That is what we are going to represent. Now, how do we recognize them? I think it's very simple. Just for no, not, none, you just see these words, then it automatically means a negative quality. Otherwise, whenever you see a positive terms like is, are, am, an affirmative declaration, it always tells you that the set is included into it. Now, again, for these quantities, for example, the all dogs are mammal, the quality is positive. I say no boy is girl, definitely the quality is reflected by the no, and therefore it's a negative. Similarly, here the not is a negative. However, if I just assign the positive and the universal as well, the quantity as well. Now, remember all and no are representative of my universal set. So these two particular quantities are definitely universal and universal. So this is a universal positive, this is a universal negative, and this is sum and sum. Sum represents a particular set, so partial set. A sum represents a p positive and a p negative. So these are my four claims or four statements as well, of the types of statement so included into it. Now, permutation and combinations of these are going to give us the four statements. That is what I've just written here, that these are four the major claims as universal positive, universal affirmative, a universal negative or a universal denial, a particular affirmative and a particular negative. So I'm sure that now you're going to easily figure out anything which represents in this manner. However, any claim that is not in this kind, for example, if I say birds fly in the sky. Now, in this kind of scenario, all we need to do is understand that this represents a universal positive, so we have to convert it to their nearest logical equivalent. So birds fly in the sky is birds as a variable. So it's a term. So it's my variable number one. And I think fly in the sky is something that I will take as a variable number two. So I have to convert this into saying all birds fly in the sky, because birds have no parameter and the null is supposed to be a universal set. So I'm going to represent this, okay, that this is my birds and these are flying in the sky. So that is what, if you do not have a statement which is given in this format, like universal positive, universal negative, particular positive or particular negative, we have to convert it into the logical equivalence, make it like the universal positive, universal negative. So let's do some more examples. For example, if I say something like actors like music. Now, actors like music again is going to be a universal positive, which I'm going to say something like, okay, there is a set of actors which particularly like music. So there are other people also that who can like music, but actors as a set definitely like music. So this is my variable one and this is my variable two. I can similarly say something like not all people are good. This is a very interesting one. This actually doesn't represent that some people are good. This actually says that some people, the logical equivalent of it becomes some people are not good. So we have their logical equivalent as a partial set of people are excluded. Please remember, the nots tell us about the exclusions of the set. So I'm going to represent it as saying something like that some people are not good. So this is my set of people, and these people are outside the set of, let's say, good. So let's say these are the people, and if they are intersecting the set of good, so I'm representing these kind of people who are not good. So because these are the people who will be good. Now, I'm sure that you can apply this to all of the questions that you will solve or you do have as a practice, uh, and try and understand them as a set, because these are the four definitely the major statements, major definite statements, and the logical equivalence of it. So let's quickly move ahead, understanding the nature of the conclusion. What is the nature of the conclusion? Now, as the statements, even conclusions will have their own quantity and quality. With the same logic, we can say all of x is y, we can say sum of x is y, and so on and so forth. So even the conclusions will have their own quantity and quality. But then what about the nature? Now, any claim that they can definitely claim is supposed to be given by the terms like is, are, etc., while any claim that they will make it probably is going to be claimed by may, might, can, could, any of these words which are going to suggest something as a probability or a possibility of events happening. So very simple to recognize whenever they say something like may, might, it refers to a probable claim that they are making or a probable conclusion that they're making. Otherwise, they refer to a definite claim that they are making. For example, in this case, when there was a conclusion, I think Socrates is mortal is a universal positive. How did I decide? Because universal has nothing as a variable, so universal Socrates will be considered as a whole set and therefore universal. And is definitely a positive set because it defines an inclusion of things. It defines an included set. So Socrates is definitely mortal, and he is referring to it definitely that he is making me understand that this is a definite claim. He is definitely claiming that Socrates is mortal. However, if he would have written it something like Socrates may be mortal, if this was may, then the claim would have been a probability. So I'm sure this is very simple enough to understand, and I hope you quickly understand. Probable, though in your exams will be only, let's say, 1% of time, 99% of your exams are going to focus upon giving you definite claims. Now, for the types of conclusions, for the mediate and the immediate, it's again very simple to understand. Mediate is the type of conclusion that is deduced from two or more than two statements. So it requires two or more than two statements. For example, if I say all A are B and I say all B are C, and then I deduce therefore all A are C. The point is that A and C is a mediate conclusion. How did I come to understand this? Because A and C are not given in one statement alone. So it involves a mediating term, which is B. Only I have to act as a B as has to act as a mediating term, and only then I can reach at A and C. So that's what I've written, that you require two or more than two statements to get to the mediate conclusion. So mediate conclusions are those which require at least two statements on the basis of which you can conclude them. However, if I would have just written a claim something like sum B are A. Now, B and A is just in one statement. It doesn't require the C, and therefore I will call B and A to be a immediate conclusion. Okay, so it's very simple to understand. The immediate conclusions are the ones which we require only for single statements, which are deduced from only single statements, which do not require any other particular statement. However, for a mediate conclusion, you require two or more than two statements. Now, I'm sure that you have adequate understanding of this. Let's move to the next part, which is upon understanding the major four terms and the immediate conclusions that if we can learn, it will be really very helpful. So as I said in the previous slide, there are four major types as a permutation combination: universal positive, universal negative, particular positive, and particular negative. So I've just given here as variables. Let's understand them as variables because these can have any value like male, human, engineer, professor, mother, women, etc., etc. So that is not at all applicable. I think what is rule is going to understand them logically, and therefore whatever is applicable to A and B, irrespectively, even if it doesn't sound good, is going to be applied to the males and humans as well, or to boys and girls, or to professors and engineers for that matter. So let's quickly understand what are the immediate conclusions. And I will again emphasize that this is something that if you memorize, your answers will become very, very quick. So what are the two immediate conclusions that we can refer from all ARP? Let's give it a thought. If I say all males are humans, I'm sure I cannot definitely say all humans are males, because then there cannot be any other species, right? That can be human. However, that claim is wrong, but I can still say some humans are males. If you're not able to process this, let me give you another example. If I say all Mumbaikars are Indians, I'm sure from this we cannot decipher that all Indians are Mumbaikars, but I can still say that some of the Indians are Mumbaikars, because they can be any other state people who can be an Indian as well. So we just remember that one fact, that out of some all ARB, we can definitely refer to some BR. And hence, in this case, we can always immediately say without any proof that some of the BRA. And also, if all of the males are humans, then obviously some of the males will also be humans. So these are the two immediate conclusions that do not require any other statement, that do not interfere with any other statement or any other mediating term to deduce any particular conclusion. And therefore, the two major conclusions immediately that can be driven from the given statements are all some BRA and some ARB. What, however, cannot be driven is all BRA. This cannot be concluded. If you have questions why it cannot be concluded, I will answer them in this video. Just hang on for a bit. Moving to the next category, which is a universal negative. Let's say if they talk about no boy is girl. Again, no boy is girl being two sets. So if I consider them as two sets, that there is a set of boy and then there is a set of girl, which are not going to intersect each other, because that's what the interpretation of no boy is girl is, right? Because it represents a whole set being outside. Remember, a whole set, no is a whole set. And how am I saying it's outside? Because it's negative. No is a negative representative, and therefore it talks about two excluded set, two things that are not going to join each other. So it's a no boy is girl is basically a two set which are not going to intersect. So there is a set of boy which are not going to intersect a set of girl, and therefore if I represent them by this, it's easy to understand immediately, without any interference, without any mediate conclusion or any mediating term of any other statement. I can immediately say three things. What I can say, I can immediately say no girl is boy, because then the set of girl also doesn't intersect boy. I can also say some of the boys don't intersect girls. I mean, let's not take it literally, but let's take it just as a set, that even a whole universal set of boys not intersecting girl and a partial set of boy is also outside girl or not intersecting girl. So some boys are not girls, and similarly some girls are not boys. So these are the three things that we can immediately say. I've just written them in an algebraic form so that you can just quickly mug them up. This is the trio that we can always deduce from a set called as the universal negative, which is no B is A, some A are not B, and some B are not A. What we can ever not say is some of the A may be B. Even in this case, the may is not possible, right? Some A may be B, nah, never. Some B may be A, nah, never. Because you have restrictively said that none of the boy is girl, so the whole set of boy is not going to intersect at any even or a single point is not going to intersect the set of girl. Now, let's quickly move to the next one, which is about understanding some ARB. Now, if some engineers are professors, I'm sure it's very simple that those are the professors that are also engineers. So I can just reverse it and immediately conclude that if some A are B, I can immediately say some B are A. So this is a very easy one. We cannot deduce from particulars a universal set. For example, we cannot say all engineers are professors or all professors are engineers because it's a partial set. It's a not a universal set, and therefore we're going to stick to the immediate conclusion being some B are A. Now, the last one is very interesting because it says some A are not B. So I've just taken a simple example. Let's say some women are not mothers. If I reverse, will this mean some mothers are not women? I mean, that sounds ridiculous. Hence, also we need to remember that a particular negative does not give any immediate conclusion. Now, having said that, what do I mean and how to quickly learn this table? I think rest of the things that is very easily manageable. I mean, you can quickly remember the no A is B, some A are B. The only two important points that we need to remember for sure that we do not make mistakes of, all A are B doesn't give all B are A, and the particular negatives do not give any conclusion immediately. So I'm sure that you will try to memorize this. If you understand it, it's well and good. But by the time the understanding doesn't happen, I will insist that you mug this up. Very, very important because this will be very handy if you just learn them. This will be very handy in terms of deciphering the conclusions are valid or invalid immediately. We don't have to draw diagrams. We don't have to draw Venn diagrams and check whether these are valid or invalid. However, let's move to the quick understanding part. Now, it's a very simple rule that affirmatives, that is positive statements, always give us a positive conclusion, and negative statements give us a definite negative conclusions. Similarly, universal statements as a whole set, we can talk about a universal set as well as a partial set. But from a particular set, we can only deduce something as a partial set. We cannot deduce a universal set. Also, the validity checks for these kind of statements are very, very important for you to understand. I mean, this is what I call it my key mantra of solving syllogisms. The key mantra is just one principle that will explain all the difficult types and the difficult variety of different variety of questions that are asked in NMAT and SNAP and DISNET. One statement that will also help you solve the questions without ambiguity and will make you understand that whatever theory I've just covered, why is even that relevant and why is even that valid? So let's understand this. I'm just asking you to understand this very, very clearly. A definite claim ka validity check is basically that if your claim is definitely claimed and it is true, by true I mean it is valid, it must be true for all the logical possibilities. However, if your claim is probably claimed and if it is true, I mean again true means valid, then it must be true for at least one logical possibility. In a short version, a mnemonic to remember this is if something is claimed to be definitely true, it is true for all. But if something is claimed to be probably true, it must be true for minimum one. What one? Minimum one logical possibility. So what are logical possibilities? I've dealt in separately. Shortly after this slide, we will look at the logical possibilities of each type of statements. But for this, I believe this is what is very, very important to learn as well as understand that for definite claims, in order to ascertain whether the claim that they have made is definitely true, you have to all look at whether something is definitely true at all sincere possibilities or not. However, if something is claimed to be probably true, it needs to be true at a minimum one logical possibility. Now, to explain this further, let me give you an example, a general example. Let's say if I say Mumbaikars are Indians. And I say Sam is an Indian. In this case, I'm very much sure if I conclude that therefore Sam is a Mumbaiker, will be a wrong claim. And if I claim Sam may be a Mumbaiker, it can be a right claim. You can pause the video and think about for it a while. I mean, this is logically very true. I've given as a sound examples. If all Mumbaikars are Indians and then Sam is definitely an Indian, I mean, calling Sam a Mumbaikar is a problem, but calling Sam probably a Mumbaikar is not a problem. I'm sure all we just did is this thing. Let's decipher how. I told you, Mumbaikars are Indian becomes a universal positive set, and Sam is an Indian also becomes a universal set. Not just because Sam is particular, but Sam as a set as is whole. The whole of the Sam is an Indian. And hence, I have to understand that Mumbaikars are Indian talks about Mumbaikar as a set included in the set of Indians. And Sam as a set is included into Indian. So Sam is definitely not going to be here. The Sam is never going to be here. So Sam is going to be here, but why do logical possibilities arrive? Because I have no idea where Sam as a set is. It is definitely inside Indian, but where? So Sam can be here. I can put it as Sam1. Sam can be here, half in, half out. I mean, for that matter, I do not know how big is Sam, and Sam can be here. I mean, Sam can also be equal to Mumbaikar and Sam can be also equal to Mumbaikars. So Sam 4 and Sam 5 also is a logical possibility. But rest a bit, how or what have I just said? I'm going to explain it in the next slides. But for this matter, I'm not going to consider the 4 and the 5 as a possibility. But definitely you will all agree with me that Sam inside the Indian can be having these 3 possibilities for sure. Now, what I just gave you as a mantra is that whenever a claim is a definite claim, and it is valid, it must be true for all the logical possibilities. Now, check. Sam is a Mumbaikar is a definite claim because you're definitely claiming that Sam definitely is a Mumbaikar. And hence, my key mantra says, my validity check mantra says that if this is true, this has to be true for all the possibilities. So I have Sam 1, I have Sam 2, I have Sam 3. Let's check whether Sam is a Mumbaikar in Sam 1. No, it's not. Whether Sam is a Mumbaikar in Sam 2. No, it's not. Whether Sam is a Mumbaikar in Sam 3. Yes, he is. So there is only one possibility where Sam as a Mumbaikar exists. Otherwise, for all the other possibilities, it's not true. And that's where the key mantra says that if something is true, it must be true for all the logical possibilities. And since Sam being a Mumbaikar is not true for all the logical possibilities, it's definitely a false claim. I'm sure you understood this. Let's move to the next one. Probably claimed. Probably claimed means something which having a may or a might as a possibility. Now, Sam may be a Mumbaikar is definitely a probable claim, and the validity check mantra says that if something is valid if probably claimed, you have to look at it and check it's probably only true once. So I just have to check whether from my 3 possibilities, whether Sam may be a Mumbaikar is true for once. And yes, I do find that Sam is a Mumbaikar or Sam may be a Mumbaikar for S3 is valid. Therefore, I consider this valid. So I'm sure that in sound arguments, it's not very difficult to understand or incorporate the logical nuances, which is, but when it comes to unsound arguments, when I'm going to call a flower a fruit or a fruit a beans or pulses, it certainly plays a dilemma in your head. But rest assured, we just have to draw logical possibilities, consider what are the essential possibilities that can arise into them. And once we thoroughly practice, this becomes very, very easy. However, the mantra is not going to change. So I think just remember this, because I'm going to use it continuously and again during my solving and as well as my theoretical classes. So please keep this in mind. In the upcoming later part of the video, I'm also going to give you shortcuts that, while not how can we avoid considering all possibilities, or what can be the shortcut of doing, and can we do land up into checking only for S3 or checking only for S1 and find out whether they are true or not. So hang on for a bit. But let's quickly move to the next segment of the video, which is about understanding the logical possibilities of each type. Now, since we have got the understanding that, okay, when two variables are concerned, what should be the logical possibilities? And it's important for you guys to understand that at least two logical possibilities with two variables like A and B should be mugged up or understood very well, because in syllogisms, more than two variables or more than three variables can also be asked, because they can give you C, D, E, and so on and so forth, and then ask you a combination of A with C or B with E, and so on and so forth. So the more possibilities arise, the more variables arise, the more possibilities arise. And therefore, if we are sure of two variables, I'm sure considering or envisaging the possibilities of all these other variables in one diagrams or in couple of diagrams are not going to be a problem. So just listen to me very carefully for the next 10 minutes. We're going to discuss the possibilities of all four types, and try to practice them while drawing the diagrams. I prefer the diagrammatic way. It's easy, it's non-burdening to my head, and it's something that I can quickly draw and check. So it will ensure the accuracy is happening. Even if I made a mistake, I can just make sure that I can quickly understand that where is the mistake happening, or I've not considered this possibility. So I insist that you quickly draw a diagram and check whether these things are not. And for drawing the diagrams, you should know and understand possibilities in its clarity. So let's begin with the first one, which is the universal positive, which says all A are B. Technically, it's tried to say the whole set of A is included in B. Now, how? I'm sure that you will understand that the all represents a whole set, and is or are represents the inclusion of the set. So basically, he's trying to say that a whole set of A is included into B. Now, why possibilities arise? Because he never tells us how. He's never telling us how is the set of A included in the set of B, and therefore it's our duty. It's imperative for us to understand that we consider the two possibilities, that how the set A can be included into B. And if you look at carefully, I think if you understand it thoughtfully, you will click and say that, okay, A as a whole set can be included into B in these two types, these two manners, in these two hows. For example, A can be a subset and can be included into B, while A can also be a whole set which is included into B as an equal set. And these are only two possibilities that you can include one set into the other. I mean, there cannot be any other possibilities if you even think of, if with respect to the two variables, for sure. Now, if you recall my immediate conclusions, which I told you to remember, in this I clearly told that all of the B can never be A. Now, why and how? Combining this with the previous key mantra that I just discussed, that if any particular definite claim is true, it must be true for all the logical possibilities. If my claim all B are true, all B are A is true, it must be true for all the possibilities, yes or no? I mean, think for a while. That out of this, if I have to say this needs to be, because you're making a definite claim, it needs to be true for all the possibilities, true for all. So is all the B A into this? No, it's not. Is all B A in this? Yes. So there is one possibility where it is true, but there is one possibility it's not true. However, I just learned that the key mantra says that if it's true, it must be true for all. All the logical possibilities should agree it. And therefore, we need to understand that all of the B or A was not being said. So this is something that we will refrain from. Whenever somebody declares all cats are dog, we're not going to say all dogs are therefore cat. We're going to say some dogs are cat or some cats are dogs, because obviously in some of the cats definitely will become dogs and some of the dogs will always become the cats. So just remember, I'm just linking the previous slides that we have just finished. I asked you to memorize them, but this is the understanding part of it, that why are those immediate conclusions infallible, or you cannot find flaws into them, or you cannot challenge them. They are going to be always true. Moving to the next one, if I say a universal negative which says no A is B, now as I said, no represents a negative set and negative sets represents an exclusion. So basically you are trying to now say that a whole set of A is outside B, and therefore the whole set of A is outside B, and there is only one possibility in this case particularly. See, the possibilities will arise, the more possibilities will arrive as new variables join the game. For example, A, B, C. Now, let's assume if I would have said no B is C, and there comes a variable C. Now, C is not going to intersect B, but do you have any problem with C intersecting A? I'm sure not at all, because I do not know the size of the A. I do not know the size of A, neither I know the size of C. So whenever new variables come into the negative, be careful. However, with respect to only single possibilities of A and B, there is only one possibility, that A and B are not going to intersect each other at any single point. So three conclusions that were driven from it immediately were: some A are not B, some B are not A, and no B is A. And all of them are going to be true at every different possibility. So just keep in mind that the trio that we have from our universal negative is no B is A, some A are not B, and some B are not A. I hope these two possibilities you have ingrained. If you have not, just pause the video, try and envisage this up. This is not difficult. Probably your mind is learning it for the first time. It might find obnoxious, but trust me, these are very simple. If you logically think about them, I'm sure you're going to understand them very clearly. The only complication happens at the next slide, which is sum. You might be thinking that sum seems easy, but no, sum is actually very complicated. Sum has a lot of possibilities to consider. So I'm sure you're going to watch this. If you are really not finding it very painful, just pause the video, take for a while, take a break, just a quick breather, and then resume the video with respect to finding out what is the wrong with sum. Sum in logic actually denotes at least one. Now, in my classes, I explain to my students like this. For example, if I say I have 10 students in my class, and I claim in a logic class, probably not in my grammar class, not in my English class, if I probably claim that some of these students are girls. Now, and I ask you, and I ask one of the students that, okay, what are the logical possibilities of the girls in the class? Let's say a minimum and a maximum. Now, if you go by logic, I think it's very simple. The minimum starts with a 1. There has to be a minimum 1 girl. And a maximum is going to be some 10. It can't be 11. I mean, 11 is illogical. Now, some people might argue or might be thinking that, what? Why 10? Why not 9? Then that's what? Not in an English class. Logical possibilities. See, in English, some means not all. But in terms of in terms of, let's say, logic, sum encompasses the possibility of all. I mean, I'm sure that this might sound a bit strange, but as to explain this more further, I say that this is therefore at least one. So sum is actually at least one. So when you say some of these students are girls, I said at least one student is a girl, and therefore at most all students can be girl. So there is a set which is starting from 1, a 2, a 3, a 4, 5, a 6, a 7, an 8, and a 9, and even a 10, which can be any of the possibility of girl. Again, understand, I'm not saying certainly that there are 10 girls, but 10 girls being also a possibility is not deniable. And therefore, sum comes with a little bit complication that when you say a part of A is B, what happens is you never told me what part. And obviously, is B means is included into B. So you never tell me how. And therefore, there are two possibilities that combine now. That what part is included? Is it 50%? Is it 25%? Is it 5%? Is it 95%? Interesting. It is 99.99%, or is it also 100%? And for that, guys, is therefore a big of problem. And then obviously, how can they be included into it? Having said that, let's begin up with minimum one and most all. These 6 possibilities are there which A can be included into B. I know that this might sound a bit strange. Do I need to consider all the 6 possibilities? No, not necessarily. But for the understanding part, at least consider 3 out of it during your exams, during your solving part. Even I will consider at least 3 of them. So, but understanding 6 is not a big problem, because you do not know examiner. They might have framed a question with a very one particular probability in mind, or they might give you a maybe or a maybe not, in which we have to consider one possibility of it. So it's better that we claim that part, and therefore let's understand the minimum of A is included into it. So minimum 1 A is included. So that's what I've drawn as a symbol, that okay, minimum 1 is B. In this case, obviously it will be a highlighted part, that this is the A that is definitely the B. Okay, so this is minimum some part of A, let's say minimum 50% is B. In this set, A is a subset of A, the whole of A, the whole 100% A is included into B. See, the whole, and it can be included as a subset, and it can be also included as a whole set. So these 2 possibilities are kind of same. So in exam, probably you can even consider 3, or you can consider 4. It will do the job fine. And then this is very interesting. A becomes a superset, and B becomes a subset. So still we can say, see, look at this area. These are the A, this is the sum part of A that are still B. Think, this is some A is B, because these are the part that is A plus B, and hence you are still being true, A even being a superset. Now that is very strange, because A can be a superset, A can be equal set, and E can be even lesser than it. And that is why sum has a horrible mess. And the 6th possibility is just the squeezed down version of the 5th, where I just squeezed the B to 1, saying that it is just one possibility, and 1 B minimum, 1 A still B. Okay, so this is the B that is still A, that is still B. Now, having said that, these 6 possibilities are something very interesting. I will use some of them during the solving of the in the next video of certain questions in the next video as well. But I hope at least for the exam you can consider the possibility number 1, possibility number 2, possibility number 4, and in certain cases possibility number 5. But 1, 2, and 4 is something that we must definitely take note of, and in certain cases even 5. Now, Sum not is not that mess, so just be cool. I think sum not has only four possibilities, because now in this case you are just trying to say that a part of A is not B, and by not you mean something like which is excluded. So now I'm going to draw minimum 1A is outside the B. In this case, definitely these are the A that are outside B. So these are the B that are not, these are the A that are not B. The A here is not B. In this case, obviously, A is a superset, and these are the A that are not B. The A that are not B. So, interesting four possibilities we can consider. I definitely, during my solving, consider all the four. But still, if you want to limit them, I'm sure that we can consider the one, we can consider the two, and definitely the four as a crazy ones. And then if time calls, we can keep three for spares. But yes, considering them will definitely help us. I think that is where the logical parts and the possibilities becomes a bit of mess, and these are with two variables. So I'm sure that you're doing it for the first time. It might seem boring, it might seem a bit of problematic to you, but they are not. Just I've explained them very clearly. So just watch this video again and repeat, I believe, or in a quick 1.5 or 2x, and you can quickly understand what is I'm saying with respect to these. There's a last theoretical aspect that also is used in certain questions, not all, which deals with the quantity and the quality. It's a very simple rule. We just have to remember six things, and we have to apply them. When two universals combine, they can give us universal or particular. But when one universal and one particular combines, when we can only talk about particular or a partial set. But when two particulars combine, actually no immediate conclusion is possible. Only immediate conclusion that comes from the single statements like this and this are definitely valid. With respect to quality, same things happen. If we talk about two positives, only give us an affirmative conclusion. If we talk about one positive and one negative, we go only with negative. And when we talk about two negative conclusions, then we have no immediate conclusion is possible. Only the immediate conclusion is possible, and that too, even if it's a universal negative. Remember, particular negatives do not take any particular conclusion. I'm just going back to the table to make you understand. The particular negatives do not have any conclusion, any immediate conclusions possible. So just keep that in mind. So this is one thing that if we somehow combine, then we can definitely answer the questions in a more clear and unambiguous, in a more accurate manner, I believe. So while drawing diagrams, there are two tips that I want to give from my side. That try and aim for drawing the negative diagrams first, and if you have positive conclusions, try to draw the least intersection diagram. What are least intersection diagram? I'm going to quickly explain you, but just for this time, just remember them. That for negative conclusions, try to draw the maximum intersection diagrams and quickly check. I think in the beginning of the video, I also told you that there is a shortcut so that you do not have to draw all the diagrams in terms of checking during the exam. But I think that's this is the shortcut that I was talking about. That if your conclusions are all negative, try to only draw a least intersection diagram and then check at whether it is happening at that point. And when they are all negative conclusions there, or more negative conclusions, try to draw a minimum intersection diagram from the possibilities, and try to solve the questions. All right, so I think that's the theory. Let's take a quick 2-3 questions. I've separately recorded a session on solving some 15 questions of all the types which have more variables, so that it will smooth your understanding in the next video. For this video, I've just taken up. You can pause the video, solve it on your own, and then I'm going to draw a diagram and make you check. Okay, So let's draw. Man is a van is a universal positive, and van is a vehicle is a universal positive. So I quickly remember from the memory that okay, the two universal give us a universal or a particular, and two positives and only give us a positive claim. So I clearly cancel the negative. The not men is a particular negative claim. So from my rule, I quickly remember that two positives give us only a positive, and therefore a negative claim is definitely gone. That's what I was trying to say, that emphasize that if you remember certain part of theory, it's going to definitely help. So negative is gone, so this is gone, and this gone means this gone and this gone. So the answer definitely lies between B and C. Now, for van is vehicle, I think this is a particular positive, and we can say particular positive. So these rules particularly can tell us, they can act like a filter. They can tell us which is not the correct answer, but they unfortunately cannot tell us what is the correct answer. For what is the correct answer, we have to draw the diagram and check. So that's why let's not stress. It helped me narrow down my choice. So I eliminated this up, and then some vehicles are men. So let's draw. Man is van is vehicle. And how is my conclusion? My conclusion is a positive. So what kind of diagram should I draw? I should draw a least intersection diagram. So let's draw a least intersection diagram and check. Man is van, okay, man is van. So man is included in van. And then van is a vehicle. So van is also a vehicle. Now this is my least intersection. So because my man is least intersecting with van and van is least intersecting with vehicle, from this diagram, can I say some vehicles are men? I think yes. These are going to be the man, which are going to be man plus van plus vehicles. So yes, some of the mans are always going to be, some of the men are always going to be vehicles. So this claim is true, and therefore the answer for this is going to be Bombay. That only two follows. How? I drew a least intersection diagram. I checked at every possibility. The least intersection possibility. Why least intersection? Because it's a positive claim. Let's check for the minimum intersection. What are the other intersections possible? There are four possibilities. For example, man can be equal to van but can be inside vehicle. Man can be a smaller set. Van can be equal to vehicle. And then man can be equal to van, can be equal to vehicle. But these are all more not least intersection. This is the least intersection possibility that we can discuss. So that's why I drew, for this one, I drew a least intersection line. Let's draw the next question. Some parrots are monkeys and some monkeys are tigers. So this is a particular positive and this is also a particular positive. Now, I quickly check for two particular positive, there is a rule. The rule is that two particular positives, the two particulars, whether it is a positive or a negative, gives us no immediate conclusion, no mediate conclusion, sorry. So they are definitely not going to combine monkey and say anything about parrot and tiger. So any conclusion about parrot and tiger is definitely wrong because they give no mediate conclusion. This is a mediate conclusion. However, some tigers or monkey is only coming from this. So some tigers are monkey. Remember, I told you to learn the immediate conclusions possible. For example, some ARB immediately gives us some BRA. And therefore, if I say some engineers are professors, I can also say some professors are engineers. And in that case, I can definitely refer and say that if some monkeys are tigers, I can say some tigers are monkey. And in this case also, I can say some monkeys are parrot. So if you say some tigers are monkey, it is coming from only this and therefore is definitely valid. And therefore the answer to this question also becomes Bombay. So both these questions, the answer was Bombay. Let's do another two. All coffees are teas and some teas are milkshakes. So this is a universal positive and this is a particular positive. If you remember the rule, we remember that U and P can give us a P and 2P plus can give us a positive. Now I see both of them are particular positive. So this rule can only act as a filter. It can help us eliminate the wrong choices, but it cannot help us get to the correct choice. So therefore, I'm going to stick to it and say that, okay, which are the two diagrams that I can draw? Now, all these are positive, so let me stick to the least intersection diagram. So all coffees are teas, all coffees are teas, and then some teas are milkshake. Some teas are milkshake. Least intersection diagram, I could have chosen to draw a diagram like this. Okay, where can be milkshake 2. I can have chosen to draw milkshake like equal to coffee, equal to tea, even greater than coffee. Remember, there are 6 possibilities of the tea. I do not know how tea and milkshake are related. He's just saying some part of tea is milkshake. I do not have any idea what part of tea is inside milkshake, what part of milkshake is inside tea, or how big is the set of milkshake and how big is the set of tea. So all these possibilities arise, but I'm not considering it for my application right now. Only I'm going to consider least intersection diagram, which is like this. Now let's check. Some coffee is a milkshake. Is some coffee milkshake in my least intersection diagram? No, it's not. And why only my least intersection is going to work? Because getting to back to my key mantra, that if something is claimed to be definitely true, it has to be true for all the logical possibilities. Remember, all. So even if it is false for one, I think I win. So it was not true. In this case, coffee is a milkshake. No, and therefore this conclusion doesn't follow. Now, is some tea coffee? I mean, tea and coffee is not. Tea and coffee is coming only from this variable, right? It doesn't require milkshake. So isn't all A or B? We can quickly say some B are A. And therefore, definitely in this case, some tea or coffee is only coming from immediate conclusion, and therefore definitely valid. So answer will be A. Now you might be wondering whether we should memorize things, whether we should draw diagrams and check. Your wish. I will insist that you memorize things because it sharpens, it quickens the process, and it gives you a certain bit of confidence that okay, this is an immediate conclusion, therefore you cannot challenge it, and therefore I can blindly mark 2 as the correct answer. In this case, okay, let's look at this one. All carrots are tomatoes and some brinjals are tomatoes. So all carrots are tomatoes. So all carrots again are not. Oh, this becomes a problem. So because this is a universal positive and this is a particular positive, this is a particular negative. So this can never be taken as true. And this is particular positive, which can be viable. So let's check a diagram. Let's positive. So we will try to draw a least intersection diagram. So all carrots are tomatoes. All carrots are tomatoes. Some brinjals are tomatoes. Now, brinjals is intersecting tomatoes. So I'm drawing brinjal as least intersection. Now, are some tomato brinjals? I think tomato and brinjals is only coming from this. So it's an immediate conclusion only driven from this. See, tomato, brinjal, brinjal, tomato. So I think there was no need of drawing a diagram at all, but even if I did drew it, it's okay. I can always say some tomatoes are brinjals and some brinjals are tomatoes in any logical possibility. So the answer to this is definitely going to be. So I hope this is going to help. Please rest assured, I'm going to solve good amount of questions into the next class. Let's take 3 variables as well, so that you can understand that okay, when more variables are put in, so let's say how many variables this has. Let's say this is 1, 2, 3 and 4 variables. Okay, so beans is first, pulse is second, crop is third, and seed is fourth. Now as I said, try to draw the negatives first. So no crop is a seed. Okay, I particularly choose a different shape for no. That's my way of solving. It's not mandatory. Besides, I think that circles are strange to draw, and sometimes people do not draw good clean circles. So it's okay that you can pick up a shape. But this is my annotation, so I just work it that way. No special reason for it. Just my annotation to just make my memory note that okay, whatever is inside crop is not gonna intersect the seed. So no crop is seed. Okay. Now all the pulses are crop. So pulses is definitely inside the crop. This is my pulse. Pulse is inside the crop. Crop is not inside pulse. So all pulses are crop. And then okay, beans are inside pulse. Oh. So I have a bean which is inside a pulse. Now, very interesting possibility. I'm drawing the least intersection because obviously I can see these are positives. So least intersection diagrams. But you should remember that bean can be equal to pulse, pulse can be equal to crop. But in no matter what, beans can never touch seed. Beans can never, pulse can never touch seed because obviously pulse will be maximum till crop and crop cannot touch seed. So let's see, what are they saying? All crops are pulses. All crops are pulses. No, not all crops are pulses. All crops may be pulses, but all crops are not pulses. Some crops are pulses. So this is gone. All beans are crops. All beans are crops. Yes, all of the beans is a subset of crop, but a crop is not a subset of beans, right? So I can say the second one. So second is true. So for this, second follows. However, if I would have written a third conclusion here and said something like, some pulses may be seeds. Please remember, this would have been a wrong one because whatever happens, even in one, not even a single possibility, pulse can be maximum till crop and no crop is a seed, right? So even in possibilities, pulses are not going to touch seed. Why did I mention this? Because see, my possibility, the key mantra also said that in terms of possibilities, for probable claims, not all probable claims are true. For possibilities also, there is at least one logical possibility must be true. So we should consider that one possibility is there and which is definitely agreeing to the path and therefore definitely valid. So in this case, third would have also been invalid. Let's consider this one. No fruit is vegetable and all potatoes are vegetables. Okay, so all along the negative is the first diagram. So let's quickly make it. No fruit is a vegetable. This is fruit, this is vegetable. So none of the fruit is vegetable. All potatoes are vegetable. So all potatoes are inside vegetable. Potatoes are inside vegetables. Now he says some fruits are apples. So this is interesting. Now apple is going to be in the other variable. Now where should I put apple? Is apple greater than fruit, lesser than fruit, equal to fruit? Is apple greater than a vegetable? Is apple greater than fruit or potato? I have no idea. So I can, making a least intersection, I can pick like this and say, okay, apple can be like this. Let's say apple 1. But a maximum intersection also, because even apple can touch potato, even apple can touch vegetable, even apple can be even bigger than vegetable. If you're having a trouble understanding and encompassing this, please go back a bit, rewind this video where I discussed all the possibilities, check. In A and B, we never know which variable is bigger. And therefore, if there are other variables playing here, for example, here there is a vegetable, potato, and apple, I have no idea that the fourth and first is related to how. So I can include apple as a lot of possibilities, I'm just numbering them. That's again my way of solving apple 2, and this can be my apple 3. So let's now check. So once my diagrams are set, I know that now examiner cannot confuse me. Then I look at my conclusions. Some apples are potatoes. Are some apples potatoes? He's saying always. He's saying are. Are means a definite claim. And something to be true definitely. I believe he's claiming it definitely. And if it's definitely claimed, it should be true for all the possibilities. So it's not true for all the possibilities. Therefore, I deny this. This is wrong. Now, some potatoes being fruits is a possibility. Some potatoes being fruits is a possibility. I'm sure that potatoes being fruits is also not a possibility because potatoes at max can be till vegetable and no vegetable is a fruit. So even this possibility is denied. So this is wrong. So in this case, the answer definitely goes as C. However, curiously, if I would have rather given something like this, that some apple being vegetable is a potato is a possibility. I'm sure. Pause a while if you can't think this would have been a valid one. Why? Because in one of the possibility as apple 3 or apple 2, my apple can touch vegetable or even my apple can for that matter touch potato. So I think that is where I end this video, guys. That's all for today for this theoretical class. I'm sure the video was a huge one and a lengthy one, but try and watch it again. If you have any particular doubt, you can reach me on Telegram at Abhipalash. I love to answer your queries. Thank you so much. I'll be recording a separate video for solving some 10-15 questions. So that's all from my side. Thank you for watching and learning, guys. I hope syllogisms will not trouble you here any further. But just the things that I've emphasized, please practice them. And thank you so much for watching.